Hello everyone. Welcome to another RevGD Rust project video blog. In today's video, we will create an AWS Lambda serverless function using Rust. This project is also based on Golang project YouTube videos, just like my previous videos in this series so far. And I will make sure to add reference to the actual YouTube video in the description below. I will also add a GitLab source code link for this Rust implementation in the video description. And just to start, AWS Lambda, as most of us are aware of it, is just a serverless option on the AWS platform. So we will just be using um, Rust to create an AWS Lambda and then upload it to the AWS cloud and test out the Lambda functions. So for this implementation, we are using the Lambda runtime. This is one of the libraries provided by AWS. It's not officially supported, but it is being managed by the AWS team. And we are using Sarde for a serialization and deserialization of the event input and output from AWS Lambda, and Tokyo for async. This also is a requirement for Lambda runtime. So after that, just going over code. So code is a very simple implementation. We will upload this binary to AWS, and only purpose is just to see if we can call this function and it executes in AWS and returns some data in JSON format. So starting from the top, we have um, we are using the handler function context and error from the Lambda runtime package. So context is just used for the function that we will be creating, and error is one of the return values uh, alongside our custom output structure. So error will be part of the result from the actual AWS Lambda handler. And then we have Sardi deserialize and serialize. Next, we are creating a custom event class. So this will be the input for our AWS Lambda function. So when we use the AWS UI, we will pass this JSON. So name and age we have to pass. And next is we are serializing it, our output. So we will just return the request ID so we can compare that request ID that was used by AWS to call this method. We received it and we just print a simple message as a message string. Next, we have our main function. So we need Tokyo as part of the AWS Lambda runtime Rust implementation. And we are using this handler function, handler fn, that is part of the Lambda runtime to hook up our custom handler method to the AWS runtime. And next we are calling the Lambda runtime run function, asynchronous call, so it will just await on this one. Uh, then we have our main handler method. Uh, of course, it's an async, we are using await before. It's a public method, and then The important thing is we are using our custom event here. So our custom event is one of the inputs, another one is just the context, and result is our custom output and error object. So error that is provided as part of the Lambda runtime, and custom output is our own structure. So context we are using to get the request ID here. So we'll just add it to our message. And here we are creating our custom output response. So request ID is the context request ID. And then we are just using the format macro to get the input, the custom event, or we can call custom input. So we get the name and the age that will be passed from the AWS Lambda CLI or the function call, and we just create this output and return it back to the user. So it's pretty simple code. Important thing is just to see how it will be used. So after we have done this thing, next we need to do a couple of things. First is we need to add target. So this is based on the documentation on AWS website. I will add link to that AWS SDK for Rust link in the video description. So we are adding a target unknown Linux. I already done it, so nothing is going to happen for me. Next thing we have to do is build in the release mode, and we'll target this x86 unknown Linux we just added with the Rust up. So it will do its thing. Once it is done building it, then we will go ahead and check the target folder. So let's see if the build was successful. So yes, we see that target x86 is created. Now we just need to copy this target output that we just created. So within that we'll have the release folder, and under release there will be executable with the same name as our project, which is in this case simple AWS Lambda. So we are copying the file and renaming it as bootstrap in our folder. So if I do here, so we have the bootstrap file now. Next, we just need to create a zip file from this. So this zip file is required to upload to AWS. This is the format it will be needed. So now we have our lambda.zip file. Next, we will switch to AWS. So I have it open and running. So we will go ahead and create a function. So lambda function from scratch. We'll just give it a name. Let's call it test func rust, or just any random name. For runtime, we'll say provide our own bootstrap on Linux 2. For permission, I have created a role. Otherwise, it will create a new role for you, and then you will just hit the create function method button. So it is done creating the function. Next step is we have to upload that zip file that we just created. So we will go ahead and upload the lambda.zip file and click on save. It will do its own thing. Once it is ready, now we can see that our bootstrap file is here under test function. Next step is we need to create a test event. So we will create a test event and let's call it whatever, it doesn't matter. So now we know we need two keys. One was name, I believe, and the other one is age. So name and age. So name we can say like Rust tester, and age, let's just say it's this numeric value of 35, or we can try with different values. So after this we'll just save this event, and now we have this thing created. So we just do the test event, and as we can see, it executed without any error. So test event name, this is the event name we used, and we can see the response. So message, as we saw in our Rust code, we have format. So name is years old. So we are getting Rust tester is 35 years old, and we can compare the request ID. So this is the same request ID that it shows in the function log here, and we are getting the same request ID here, and we can see even see it at the bottom. So that shows that we are able to create a Rust AWS Lambda function, upload it, and test it out, and everything seems to be working fine. This will be it for today's video. Thanks for watching, and I'll see you in the next one.